Before we teach a single rule, look at this. 7 and 2 and 3 little print statements. Slash, double slash, and double star. Can you already say with confidence exactly what each line prints? If there's any hesitation, this lesson is for you. Python rewards you for reading code slowly, watching each line change the state of the program. So that's exactly how we'll learn it. We'll run code and watch it think. Start with the atoms of every program. Variables. A variable is just a name pointing at a value. The equal sign isn't a question, it's an arrow. Take the value on the right and let the name on the left stand for it. Line 1, n is assigned 5, a whole number, an integer. Watch the panel on the right. N holds 5. Line 2, pi is 3.14. That dot makes it a float, a decimal number. Line 3, name is the text other, wrapped in quotes. Text in quotes is a string. And line 4, OK is true, capital T. True and false are the two booleans. The yes and no values every decision rests on. Now the type function. Line 5 asks what type n is. Class int. Line 6, pi is class float. 4 core types: int, float, str, and bool. Knowing the type of every value is the whole game, because the type decides what each operation does. Now arithmetic. Set a 2-7, B22, and march down the operators one at a time. Watching the console, fill in. Plus and minus are what you'd expect. 7 plus 2 is 9. 7 minus 2 is 5. Star is multiply. 7 times 2, 14. And double star is power, not the little caret you might expect. 7 to the power 2 is 49. And here is the one that trips everyone. A single slash is true division. 7 divided by 2 is 3.5. Notice, even though 7 and 2 are both integers, the answer comes back as a float. In Python, slash always gives you a float. A double slash is floor division. It divides, then rounds down to the nearest whole number. 7 over 2 is 3.5, and the floor of that is 3. So double slash gives a clean integer, 3, and percent is the remainder. What's left over? 7 over 2 is 3, remainder 1. So 7% 2 is 1. The remainder is your best friend for testing even and odd. Hold these two apart. Slash gives a float. Double slash gives a whole number. And even 6 divided by 2 returns 3.0, a float. That surprises people every time. Strings are text, and they're everywhere in data work. Let's build one up. First is the word data. Second is the word rekha. Line 3 joins them with a plus sign. For strings, plus doesn't add. It glues, end to end. So full becomes DATAREKHA, one word. Line 4 prints full, and its length. The lay function counts the characters. DATAREKHA has 9 letters, so it prints DATAREKHA, 9, and F strings, the cleanest way to drop a value into text. Put an F before the quotes, and anything in curly braces gets computed and slotted in. Age is 21. So F, I am, age in braces, prints, I am 21. Now indexing. Every character has a position, and positions start at 0, not 1. Here is the word laid out. The top numbers count from the left starting at 0. The blue numbers count from the right starting at -1. So S at 0 is the first letter, D. Watch the box light up. And S at -1 is the last letter, a reaching in from the right. And lay of S is 9, the count of characters. Concatenation, F strings, indexing, length. You'll reach for these constantly. To make decisions, code has to ask questions, and questions return a boolean, true or false. These comparison operators are how you ask. Double equals asks, are these equal? 3 equals 3, true. This is the great beginner trap. A single equals assigns a value, but double equals compares. One sets, two asks. Exclamation equals asks, are these different? 3 is not 4, so that's true as well. Less than and greater than do what they say. 3 is less than 4. True. 3 greater than 4. False. Then you combine questions with the words and, or, and not. And is only true when both sides are true. True and false, false. Or is true when at least one side is true. True or false, true. And not simply flips it. Not true is false. With these 6, you can phrase any condition you'll ever need. Now decisions. If, elif, else. Python checks each condition top to bottom, runs the first one that's true, and skips the rest. And notice the indentation. Those 4 spaces are how Python marks which lines belong inside a block. Score is 72. First check, is score at least 90? 72 is not, so this branch is false. We skip its block entirely and fall through. Next, elif, is score at least 60? 72 is, so this one is true. This is the branch that runs, so we run its block. Grade is assigned the letter B. Watch the variable panel. Grade appears, holding B. And because one branch already matched, the else is never even looked at. The final line prints grade, the letter B. Trace which branch runs, and conditionals hold no mystery. Loops are where the magic is. A few lines do a great deal of work. The classic, add up 1 through 5. Start total at 0. Line 2, for I in range 1 to 6. A crucial rule. This gives you 1, 2, 3, 4, 5. It stops just before 6, not at it. First pass, I is 1. Total becomes total plus I. 0 plus 1 is 1. Watch it tick up. I is 2. Total plus I. 1 plus 2 is 3. I is 3. Total plus I. 3 plus 3 is 6. I is 4. Total plus I. 6 plus 4 is 10. I is 5. Total plus I. 10 plus 5 is 15. Range is exhausted. So the loop ends and prints total. 15. You watched it climb 0, 1, 3, 6, 10, 15. That living panel is the best habit you can build for reading loops. One more flavor. A for loop doesn't only walk over numbers, it walks over any sequence, including the characters of a string. For ch in the word cat, ch becomes C, then A, then T, and we print each one. 3 characters, 3 passes. C, A, T. Same loop, walking a string instead of a range. A for loop runs a known number of times. A while loop runs as long as a condition stays true. You don't say how many times up front. Here's a countdown. N starts at 3. The rule. Keep looping while n is greater than 0. Each pass we print n, then knock it down by 1. The danger. Forget that last step, and n never changes. So the loop runs forever. Watch n shrink each round. N is 3, greater than 0. True. Print 3, then n drops to 2. N is 2, greater than 0. True. Print 2, then n drops to 1. N is 1, greater than 0. True. Print 1, then n drops to 0. Now n is 0. Is 0 greater than 0? No. The condition is false, so we fall out of the loop. The final line prints liftoff. 3 numbers counted down. Then we're done. Your turn. This one pulls together almost everything. A for loop over range 5, and inside it, a decision using the remainder. Pause the video right here and write down exactly what it prints, line by line. I'll wait. Let's run it together. Range 5 gives k 0 through 4. For each k we ask, is k remainder 20? If yes, even. Otherwise, odd. K is 0. 0 remainder 2 is 0. So even, prints 0. Even. K is 1. 1 remainder 2 is 1, so odd. Prints 1 odd. K is 2. 2 remainder 2 is 0. So even, prints 2 even. K is 3. 3 remainder 2 is 1, so odd. Prints 3 odd. K is 4. 4 remainder 2 is 0. So even, prints 4 even. 5 lines. 0 even. 1 odd, 2 even, 3 odd, 4 even. If your prediction matched every line, you've absorbed loops, conditionals, and the remainder all at once. Real progress. Trap 1. The classic. A single equals assigns a value, double equals compares. Use one where you meant to, and your condition breaks silently. Trap 2. Slash always gives a float. Even 6 over 2 is 3.0, not 3. For a clean integer, reach for double slash. Trap 3. Range 5 is 0 through 4. It stops before 5. Off by 1 errors live right here. Trap 4. Python has no braces for blocks. Indentation is the structure. Line up your spaces, or the code runs the wrong lines. Let's gather it all. 4 types run everything: int, float, string, and boolean. Arithmetic's sharp edge. Slash gives a float, double slash floors, double star is power. You ask questions with comparisons and join them with and, or, and not. Decisions use if, elif, else, and indentation marks each block. And loops do the heavy lifting. For when you know the count, while when you have a condition. The habit that carries every code lesson ahead is simple. Read a line, watch the variables change, see the output, run it, and watch it. Think.